Hello, today we will be discussing different types of system based on the architecture and the various different kind of services provided by the operating system to the user and to the system itself. So we have seen in our previous session the different kind of the evolution of the operating system, how it has been evolved from batch OS to multitasking. Today we'll be discussing based on the computer architecture the different kinds of computer system. Based on the architecture, there are two different kind of computer system, single processor and the multiprocessor. In case of single processor, there is only one CPU in the computer system which has the ability to execute one general purpose instruction. In single processor system, there is a limitations that it can execute only one instruction at a time. Whereas in case of multiprocessor system, as the name suggests, it has more than one CPU and it can execute more than one task at a time based on the number of processor available in the computer system. The multiprocessor computer system is also known as parallel computing system or tightly coupled system. As the name suggests, parallel because it can execute more than one instruction or more than one general purpose instruction at the same time. So that's why it's called parallel computing system. So this kind of system has got more than or greater than equals to two general purpose CPU. CPU is basically a hardware. So this kind of system basically shares various computer resources like computer bus, memory, and various peripheral devices like mouse, keyboard, etc. In this kind of system, there are several advantages which I am going to explain. First advantage is throughput. In case of multiprocessor or tightly coupled system, there will be obviously an increased throughput because there are more than one CPU available for executing the user instruction. In contrast, single processor system has the ability to execute only one instruction at a time, whereas in case of multiprocessor system, it has the ability to execute more than one general purpose instruction at the same time based on the number of CPU available. Say for example, in a dual core system, there are two CPU, and in a dual core computer system, since there are two CPU, it has the ability to execute two instruction or two general purpose instructions at the same time. That's why we say here one of the advantages of multiprocessor system as an increased throughput, because it is obvious that it can execute more amount of instruction at the same time in contrast to single processor system. Next advantage is economy. Suppose X is the amount that you have wasted or you have used in order to buy a single processor computer system where you have got monitor, you have got mouse, keyboard, memory, etc. Similarly, you have purchased multiprocessor system, say for example dual core system, which also have got mouse, keyboard, monitor, memory, etc. Okay, so the amount of memory and the quality of monitor, keyboard, and mouse are of same that you have used in for single processor system. So if you compare the amount for buying the single processor system, multiprocessor system, it is obvious that multiprocessor system will be economy. Why? The reason I'll show you. So say for example you buy a same configuration computer system. Okay, so you have bought two computer system of same configuration. Okay, so and you have bought uh, one computer system or multiprocessor system with some value of same configuration, then it is obvious that the amount you will be wasting to buy a multiprocessor system with same configuration will be much less than buying the two of same configuration computer system, because in case of multiprocessor system you will be sharing monitor, memory, mouse, keyboard, etc. So you will not be wasting, unlike in buying two computer system of single processor. Okay, so it is obvious that the amount with which you'll be buying the monitor, or the amount required to buy monitor, mouse, keyboard, memory, etc. will be reduced. So that's why it's called, okay, economy in scale. So in short, buying two single process system of same configuration will be cheaper than buying single multiprocessor system, as most of the resources will be shared, like monitor, memory, peripheral device, etc. So that's why economy is scale. Next is the increased reliability. So if consider a system of dual core system with some configuration, and suppose one CPU fails, then it is very obvious that the other CPU will handle the situation or will continue the execution of user process. But whereas, or in contrast, if you talk about the single process system, if one system fails or if one CPU fails, the entire system collapses. Okay. Now let us talk about the types of multiprocessor system. There are two different kind of multiprocessor system: symmetric and asymmetric. In symmetric multiprocessor system, there are multiple CPUs and multiple process parallel in executions. So each CPU will execute each different process. So multiple tasks at the same time. Such kind of symmetric multiprocessor systems share common memory, common resources, common register. Okay. Next, another type of multiprocessor system is asymmetric multiprocessor system, which basically uses the concept of master slave. Here, out of many CPU, one CPU will be considered as a master and will entirely working on behalf of the operating system. That master CPU will assign to different CPU the process for execution. So basically, it uses the concept of master slave architecture. Next, with the advancement technology, we'll discuss distributed system. With the advancement in technology, we can connect multiple computer systems together in a network. There are several advantages of doing so. Some of them are resource sharing, computational speed up, reliability, increased reliability, and communications. So whenever anybody is designing a system, a distributed system as shown in a diagram, always it has to keep in mind that there is absence of global core and there is absence of shared memory. Means that there is no common clock and there is no common memory location where each and every different user of the computer system connected via network can store their information. So now with the advancement technology, it is practical that we can connect multiple computer system using the network in the small area or in the wide area. So there are several advantages which I'm going to explain. First of all, resource sharing. Suppose there is a huge information which I want to store in a computer system. Now, since there is a limited memory space, okay, and the amount of memory required for storing such information is very large, you can accommodate entire thing in a one computer system. So in such kind of system, and if you have got such kind of network environment or distributed environment, then you can divide the information in small segment and store it into different computer system. Okay, so it's called divide and store. Next is the computational speed. Similarly, if you have got this distributed system where different computers are connected with each other, and you have got the user program to execute. Now all those user program which have got, say for example, the user program have got hundreds of subroutine. Now those hundreds of subroutine, if it has to execute in single system, then one after another it has to execute. Whereas in case of distributed system, so function 1 can be executed here, function 2 can be executed here, function 3 can be executed, and then so on. Like that way you can distribute the execution of different subroutine in the different computer, provided those subroutine are independent of each other. Next advantage is the reliability. Reliability means your system has to continuously execute if some system fails. Say for example, this first system fails due to some problem. Maybe network is gone or something problem is there. Then in that kind of situation, the other system still continues to perform task. So it will increase the reliability. Next is the communication. So they can communicate with each other for sharing of information. Say for example, one person is located at one location, another person working in another computer system is geographically located very far. So if they want to share information, they can very easily share information without moving from one place to another. Okay, so it saves the time as well. So to have such kind of system, we need a special kind of operating system called network operating system that should provide some features like file sharing. How can you share the information, or you can share the file between these two nodes or two computer system connected via network, and how can you communicate now? Okay, how can you allow communication between those two nodes or the system? Okay, so this is all about the distributed system. This is a very brief, okay, about the distributed system. Now you must have always heard about the very common architecture of the distributed system, like client server architecture, client server system. Okay, in client server system, the client server system is a special type, a special case of distributed system in which only two systems are connected with each other. One is the server and the one is the client. The client will give some request to the server will process the request and send the result back to the client. So for example, you want to search something in a web. So for example, you want to search something in a web, then you give some keyword into the Google search bar, right? And you hit the search button. That keyword will be received by the server, Google server, and will be processed, and whatever is the result will be sent back to client. So this is very simple client server architecture, and it's one kind of a special case of distributed system. Now, since now we have studied special, now we have studied different kind of computer system based on the architecture. Now, based on the application, there are different kind of system. First one is the real-time embedded system, or in short, embedded system. Okay, that is basically designed for accomplishing some special kind of task. For example, microwave oven. For example, smart TV, and for example, washing machine. You may consider this example because in this kind of system, there is special OS that is installed in it that serves certain purposes only. Next is the multimedia system that is basically used to handle the multimedia like video file, processing of video files, audio files, image files, etc. Next is the handle system that handle system, a system that is something you can hold in hand like PDA, your cell phone, etc. Handle system designer have some big challenges that in a small within a small area you need to accommodate so many things, keeping things in performance in in the mind of the designer. Okay, so these are the different kind of system that you can explore on your own. I've given the rough definition. So now we will move ahead to uh, real time, the operating system pertaining to real time embedded system. So why real time is attached with it? Because uh, time constraint is attached with it. Okay, any system which is a real time should accomplish task within a given time frame. Okay, it should definitely complete its task. Let me give you an example. Say for example, bottling. Okay, bottling. So in case of factories where bottling is done, okay, What they used to do is that bottle will come in a row, and there is a machine, okay, hanged over ceiling, okay, that will put a cap on top of bottle. So in a in an equal interval it has to put a cap on top of bottle. So that is an example of real time system. So in order to run a real time embedded system, there is a special kind of operating system design, that is real time operating system. So real time operating system basically works on the principle of time constraint. It has got well defined fixed time constraint that it should complete its task. Now if within a given defined time constraint, if it does not complete its task, then it indicates that system will fail. There are two different kind of real-time system. One is a hard and the one is soft. In case of hard, if the system fails because it has not made the time constraint, then some disaster will happen. Whereas in case of soft real-time system, if time constraint fails, then it hardly makes any difference to the user. Let me give an example for hard and soft, okay, one each. Say for example, hard in nuclear plant and all, okay, if some wrong button is pushed, okay, for some wrong regions, then it will create a disaster. For example, in case of soft, suppose you want to search some information in the internet, and you have given the search options in the Google. Now due to poor internet connectivity, you might not get the result. So that is an example for the soft real time system. Okay, so that's all for the real-time operating system. Now we will talk about the operating system services. There are list of services that operating system will provide to the user, and list of services that operating system will provide to the system itself. System itself is computer system. Let us take one by one each. Okay, first is the system services, operating system services provided to the user. So one of the very important is the UI, that is user interface. Each and every individual gives services of UI to the user. There are different kind of operating system like Mac, Windows, Linux. You must have seen, some of you must have seen all three and have seen that different UI is given. Okay, so let us talk about some basic thing only. So some of the common user interface classifications is a CLI, BI and GUI. CLI stands for command line interface. In command line interface, you give the command on the console or the command prompt for execution. Operating system will interpret that command and will do some task. Next is the BI, batch interface. BI stands for batch interface, where group of command were grouped together and stored in a file, and an operating system will execute group of tasks at a time. Okay, so in batch OS, it allows the user to give batch of command. And the last one is the GUI. GUI stands for graphical user interface, very common. Nowadays, all the operating systems are based on the GUI for ease of usage. Okay, which is one of the objective of designing the operating system. Ease of operating system usage is very important. So GUI plays a significant role. So GUI is, through GUI the user can interact with the computer or give the command or the instruction to the computer system or the operating system to perform some task. Next is the program execution. So operating system should provide a service so that the user can execute the user program efficiently. User can execute the user program efficiently. How? So the operating system should be able to locate the user program, load it into the computer memory. If there is no memory in the RAM, you need to find it out, or the operating system need to find it out, the free memory space, load the program, manage the memory, and then start executing. For starting executing, it need to assign the resource, so it should execute the program, and at the end it should provide the result. It should terminate the program. Okay, so the termination of the program can be normally or abnormally. If it is normally terminating the program, well and good. If it is not normally, or it is, if the program is terminating abnormally, then it should give the information to the user, abnormal termination along with the regions. So program execution has to take smoothly, and um, uh, that is the task of the operating system, the smooth execution of user program. Now next is the IO operation. During the execution of the user program, the process the process may demand for some peripheral device or like printer or IO device, okay, so, or user input. So whatever we will scenario, it is the job or the task of the operating system that whenever the process is demanding any IO services, then it should give the resources to that such process and keep track of it. Next is the file system manipulation. Operating system should also allow the user program to create a file, to delete a file, to search some file, or to modify the existing file. So it should allow various file handling operations. Communication. So now in a system, in a computer system or in a multiprocessor computer system, it may happen that two or more processes are executed concurrently being executed or simultaneously being executed. So in such kind of situation, those two processes may want to communicate with each other. So it is the job of the operating system that it should provide a medium with the help of which those processes should be able to communicate with each other. So basically communication in operating system is generally implemented with the help of message passing or the shared memory. Okay, so message passing means one process will share the will send the message to another message through some medium through some bus with the help of bus. Another one is the shared memory. One common memory will be assigned to those two process, where one process will write it, another process will read it, and another process will write it, and another process will be reading it. So that's the concept of shared memory. Another one, last one is the last services that is provided to the user by operating system is the error detection. So operating system should be aware of all possible errors that it may encounter. It should know each and every different kind of error that it may arise during the proper normal flow of the computer system. So having detected any kind of error, it should perform or it should act accordingly. The operating system should act accordingly based on the detected error so that consistent operation is being performed. Next is the we will discuss now the list of services provided by the operating system to the system itself, to the computer system itself. The first one is the resource allocation. So there are so many different kind of resource attached with the computer system. All the management of resources, like for example CPU, memory, IO device, all these resources has to be managed by the operating system. Management, it should keep track of how many resources are there, who is being allocated which resource, when you have to get it back, etc, etc. So basically the main job of the operating system to act as a resource allocator. Okay. Next is the accounting information. So a computer system, a single computer system may be used by more than one user. So it is the job of the operating system to keep track of all possible users and various resources that is being used by different users. So all accounting information, all accounts, it has to keep track of it. The number of users, the number of resources used by the different resources, sorry, the number of resources different used by different users. And the last one is the protection and security. Now it may happen in case of multiprocessor system that two or more process is executing concurrently. Two or more process is executing concurrently. So it is a job of the operating system that those two concurrently executing process should not collide with each other, should not disturb or intersect with each other. So smooth execution of concurrent has to be ensured by the operating system. Now, apart from that, OS also operating system should also ensure that the resources that is being allocated to different process or the different process are to be accessed dispersed in a controlled manner so that you do not enter in a deadlock situation. So those things has to be kept thing in the mind of the kept thing in the services of the operating system. And the last one is the security. Security is very important because during the execution of the user program, the security of the execution of one program should not hamper the execution of another program. So there may be two or more programs executing concurrently in system. So both the execution of the program should be secure to each other. In addition, it should also check operating system should also check that the execution of certain program may not access its internal code like kernel code or system32 file code for that may disrupt the normal execution of the computer system. So system32 files are considered to be very very critical file. Nobody should have the access, and nobody should have access to for modification. So if something some files has been deleted from the system32 file, then your computer system may not work properly. I'm giving this example with respect to Windows system. So in short, the operating system has to ensure the security for execution of user program. In addition, it also has to ensure itself that outside program is not disturbing itself for normal execution. I hope I had made it clear. Thank you. If you have any questions, please post. Thank you.